afternoon, everybody. My name is Verletta Kern. I'm excited to welcome you to the Open Scholarship Commons. This is an interdisciplinary space designed to explore best practices for creating and sharing research and making the impact of research visible to the world. So we're really excited today to host the first of our Open Scholarship Commons Community Fellows Workshop Series. These are workshops that are designed by graduate students. And these graduate students have worked really, really hard throughout this process. They were selected through a competitive process in the fall quarter. They spent winter quarter working with mentors on developing their workshops. We did a dress rehearsal last week and gave feedback on everybody's workshops. They're really fantastic. We're really proud of our fellows and excited for you all to see the work that they've been doing. I want to take a brief moment to thank our co-sponsors, the eScience Institute and the Diversity Seed Grant, who helped make these workshops possible. And then after this workshop, I'd love to encourage you to continue conversations. We have snacks. Have a snack. Chat with Ather, chat with others about data visualization and accessibility. And so at this point, without further ado, I'm going to turn it over to Ather.
Thank you so much. Thanks for all coming. Really appreciate it. First, as just the first thing to say is that really thankful for the Open Scholarship Commons and the library for giving all the grad students, including myself, the opportunity to present this workshop. Thank you so much. And thanks for being here. So we'll get started in about a couple of minutes. This workshop is obviously about making data visualizations accessible to screen reader users, but there's a QR code. This QR code is for a pre-workshop survey. That survey is going to really help me in my research. If you don't mind taking your phone out, getting the QR code, there's a link there as well. And if you could just fill that survey out for me, I would really appreciate it. We'll give you guys a couple of minutes, 2-3 minutes before we get started. All right, let's get started. And please feel free to complete the survey during the presentation of the workshop as well. So let's get started. First, just as a quick introduction, my name is Ather. I'm a PhD candidate at the University of Washington here at the Paul Young School of Computer Science and Engineering. I use he, him pronouns, and my research focuses broadly in the area of human-computer interaction, and specifically in the intersection of accessibility, visualization, and personalization. What does that mean? That really just means that I make online data visualizations accessible to screen reader users, right? So a little bit more about my research. This is the White Tree of Gondor. It was destroyed by Sauron, but it is very much alive for me. And as like in this tree, my work is rooted in the area of accessibility, and it has branches into the fields of personalization, AI, ML, NLP, visualization, disability studies, and interaction techniques. And broadly, it's in the area of human-computer interaction. So what we'll do today in this workshop is we'll have 3 different sections in this workshop, right? So first, we'll discuss what the problem is. What does that mean when we talk about accessibility of online data visualizations? What is really the problem? We'll discuss that a little bit more. Then we'll talk about the common practices that are used to make those data visualizations accessible. We'll discuss some of the modalities. We'll have a nice little activity and things like that. And then finally, we'll talk about what is outside of those practices, what is being done in this domain today to make those data visualizations accessible. And that is a section on future avenues. So far, you've heard me say this term quite a bit, screen reader users. What does that mean, right? So screen reader users are users who utilize a screen reader to read the contents of their computer screen. They may have conditions including a complete or partial blindness, low vision, learning disabilities, or motion sensitivity. So when we start thinking about accessibility, the first thing that comes to our mind is blind or low vision users, right? But screen reader users are not only blind and low vision users. They are users who use screen readers. They can use screen readers for temporary purposes as well. So just for example, someone might have motion sickness, and for that, they might be using screen readers. So our work is target those users who use screen readers and to target that broader population and not just limit ourselves to blind and low vision users. Another term that you've heard me say so far is online data visualizations, right? So why is it important that we target this particular domain of online data visualization. This is because the online data visualizations are being increasingly used to communicate essential insights that assist people in making critical and informed decisions for themselves and their families, right? So for example, there were these three visualizations which were very, very common a few years ago. On the right side, we see this visualization. Well, not the right side, sorry. It's on the left side of the screen, because my right side, sorry. So on the left side of the screen, there's a visualization from the King County, which shows the hospitalization during the COVID-19 era. This is done by a choropleth map, which is a map which is shown by color. So it's obviously like helpful to determine which shade of color represents a higher amount of data or values. Similarly, we have a graph here that was published by the Seattle Times. That's on the top right, and on the bottom right, we have this graph of there's a bar chart that shows the COVID-19 cases per U.S. state. Now, these are very important visualizations. We saw them every day. This helped us in making a lot of important decisions in our life, right? Also think about like financial data, stock market trends. They're mostly communicated through visualizations, and they're really important for us to make decisions, right? But we are visual people. It's in the term, the visualizations. It's of an inherently visual nature. So what about people who are blind or have low vision? What about people who use screen readers? What do these visualizations mean to them? How are they able to extract information from these? And this is why what we're going to discuss today is the problem. The problem is that they're not able to access these visualizations. So let's take a deeper look at the problem of online data visualization accessibility. To do so, we'll first demonstrate an interaction of a user with using a screen reader with this visualization that we saw earlier of COVID-19 cases per US state. So let's see how that looks like. So
This page from Google Results says I can get the latest COVID-19 data for the US states. Let's see if I can find out how my state, California, is doing compared to other states.
Heading Level 1, COVID-19 cases per U.S. state. A bar chart showing the COVID-19 cases for the states in the United States. Image, you are currently on an image inside of web content. To begin interact, no visible title to interact.
Oh well, there's alt text that says there's a bar chart, but where's the data? I guess these visualizations are not for blind people like me.
So what we just saw was not something that I curated for this workshop. This is an actual interaction of an actual user in one of our studies. So what we're seeing here is that all they got was the title of the visualization, and that's it, right? Nothing else, no data, no more information. And that, unfortunately, is the state of how visualizations are today, where they're not able to extract information. And even if they are able to extract information, that's very, very limited in a lot of ways, right? As a matter of fact, one of my research has shown that due to the accessibility of these visualizations, these users extract information about 62% less accurately and spend about 211% more time on these visualizations compared to those who don't use screen readers, right? So what we have here are two graphs that are, one is a bar chart, which shows their accuracy across three different kind of visualization libraries, which are very, very common libraries to use, that we use to create visualizations online today. And then we also see an interaction plot that clearly shows that the accuracy of these users is drastically different than those from those who don't use screen readers. And similarly for interaction times, their interaction times are much, much higher than those who use screen readers, right? So obviously at this point, we have to ask the question that, is this acceptable? And clearly the answer to that is no. So to dig a little bit deeper into it, to understand a little bit more, we have a co-presenter today. His name is Kunal Mehta. Unfortunately, he couldn't be here today, so we have recorded an interview with him. So we'll go into that, and we'll hear some of his opinions and some of his thoughts. So hopefully that will motivate us for the rest of the workshop in why this problem is a problem and why this problem is really, really an important one, right? So, well, he's not here, but I relate that to him. That please welcome Kunal Mehta. Hi, Kunal. Thanks for joining us today. Kunal, would you like to introduce yourself to the workshop attendees?
Sure. My name is Kunal Mehta. I use he, him, his pronouns. I am a master's student in the Human Centered Design and Engineering program at UW. In fact, graduating this year, so excited. I before this, I was in India where I worked across a couple of different industries, and yeah, I also have a background in business management. So I do have an MBA before this. So uh, yeah, excited to speak to you on this.
Great. Kunal, do you consider yourself a screen reader user? Could you talk to us about that?
Yes, I am a screen reader user, and I primarily rely on screen readers to get most of my work done. I am totally blind. I've been blind more. I mean, I could see a little bit as a kid, but for all practical, functional purposes, I've been blind mostly since birth. So yeah, it started with me having cataract from birth, which was fine, which wasn't a big deal. But then um, slowly developed into glaucoma, issues with glaucoma, and yeah, I guess cutting the long story short, kind of vision kind of deteriorated. Uh, I had no vision since I've been, let's say, 8 or so. Yeah, since the age of 8. I could see a little bit. When I say a little bit, like make out colors, uh, figure out objects in front of me and things like that before that. But after that, I think it's practically been no vision. I use JAWS screen reader more so, a little bit of NVDA on Windows, and then VoiceOver on the iPhone.
Thanks for sharing, Kunal. Could you talk to us about your experience with accessibility on the web?
So I think when it's implemented thoughtfully, when the right HTML markup and stuff like that is used, it's much easier. But then not everyone thinks about it. So there's just so much. Otherwise, there's just so much randomness on so many websites, and it might still qualify as being accessible as per certain guidelines and things like that, but it might not be a great experience. I mean, I might still be able to get my work done, but then it would take like 20 to 50% more time. So yeah, that for me is a bit of a failure. There's a disability tax that comes into play, right? When I say disability tax, it's anything of your resource, and time is such a precious resource. If you need to spend more than what somebody else might do on an average, I think it's not a great state of affairs in that sense. So in that sense, yeah, there's probably a lack of equity in some sense.
Thanks, Kunal. How would you describe your experiences with accessibility of online data visualizations?
I guess the most recent one is probably a bar chart that I would have. I mean, we encountered those in so many places, and maybe it's accessible. They are trying to make it accessible. I don't know, but it's funny the way it reads out to me. Let's say there are values 1, 2, 3, 4, 5 through 10, and then there are like other subsequent values related to that. It could be I don't know, just let's say number of people falling under each bracket. But strangely, the screen reader would read out to me 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the other set of values, which is 10, 20, 30, 40. So now what do I need to do is I have to figure out, okay, the third value is 3, and the third value in the corresponding column is 30, let's say, and in my head I have to make that match, which takes more time. And I mean, we are just talking about very simple example right now, but then not all examples or not all data or not all visualizations are similar, right? Stock prices, right? I like to follow stock prices sometimes of certain companies or just the overall space, and it's hard to follow. I want to look at different parameters like the 52-week high, lows. What was the trend in the last month, 1 month, it's super hard, and even getting a gist of it, uh, it's difficult. It can get, so I wouldn't say it's like impossible to figure that out, but you eventually tend to give up because it's so time consuming, and you tend to sort of just give up, saying, okay, I probably don't want to do this.
I appreciate your response, Kunal. Could you talk to us about some of the traditional solutions to make data visualizations accessible?
Providing a textual summary in whatever form. It could either be alt text, or it could be something that's available to all. Providing that is a good way, again, for static data. But yeah, I think the simplest way to do is providing the data in a table form. And I know it's not always possible, but then it gives the opportunity to the individual, if they need to play around, if they need to make their own interpretations and stuff like that.
I know you talked about alt text, which is a very common strategy. Do you think alt text is sufficient as an accessibility measure?
No, because I don't really know what I'm missing out on. Even if somebody might have done alt text really well, and I know we have AI generated text and stuff like that now, but I am still not 100% sure if I have everything that I need. What would have happened if I would have looked at the data? Maybe I would have just interpreted something in a different way, or I would have just seen something that somebody doing the alt text, or the large language model doing the AI generated description didn't catch it, right? Ideally, I would like to have both, so that I'm sure of what I'm looking at and what I'm trying to work on, because sometimes implications can be quite drastic in terms of getting the data right. Or I mean, if you don't get the data right, there can be dire consequences. So yeah.
Got it. Thanks, Kunal. If you were to describe the state of accessibility of online data visualizations in a few words, what would you say?
The progress is too slow, I would think, in making making things accessible. So I guess the actual data visualization space is progressing so rapidly that anything that's being done, the gap is just being widened. Not even, the gap is not even equal. I think the gap just keeps widening.
Agreed. Once again, thanks for being here today. I have one final question for you. Is there anything you'd like to say to the attendees today?
I think, first of all, it's a great start that that you're here, because I guess that's the biggest step that one could take, just to try and learn. Now that you're here, I would say try and understand and learn as much as you can, but yeah, don't get overwhelmed and give up. Any progress anything that you're able to do, if you're able to maybe change one process to make maybe 5% of something more, of a visualization more accessible in the content that you create, that is great. And that's where and if most of us start doing that, we'll be in a much better space. So you don't know how much indirectly that can affect people positively. So yeah, just keep going.
Very well. This was Kunal.
Hi, Kunal. Thanks for joining us today. Kunal, would you like to?
Okay, so that was Kunal, and obviously we're really thankful for him for sharing his opinions and thoughts, and everything that Kunal has said has inspired me and motivated me, and I hope that it has done the same for you as well, at least for this workshop and even after that. A lot of things that Kunal said sets a motion for what we are going to experience in the rest of the workshop. Also, there's a QR code for Kunal's this video. If you wanted to listen to it afterwards, please feel free to do so. Kunal is also really willing to connect with you all and to answer any of your questions. So here's Kunal's email and his LinkedIn profile if you would like to connect with him after the workshop. But other than that, with that said, hopefully we have a better understanding of the problem and the frustration of the community that they face in making these data visualization, extracting information from these data visualizations. So now let's discuss some of the common practices. So in this workshop, we'll kind of discuss some of the common modalities that are used, and we'll discuss how they work, how they don't work, things like that. But first, let's start with the most common modality, which is the alt-term text. So we heard that from Kunal. We also know that as a very common strategy, that anytime someone says make something accessible, the first thing we hear about is alt text, right? What is an alt text? Alt text is a actual description that describes an image, that describes the data, so users can get information about what it is. And it's very common, and it can be very effective as well. Like for example, here we have a graph and an auto-generated alt text off that graph. Now, what that tells you is that this is a horizontal bar chart. It has a title, and the title is EvoGraph's bar chart. It also tells you about the data that is contained in that graph, right? So it can be really helpful for people to understand as a holistic information about like what this graph is about, what the information is, right? So that's one of the most commonly used modalities. Let's take a look at another commonly used modality. So this is sonification, and we'll play this as well. But sonification is a strategy to use non-speech audio to represent the data in the graph, right? And I know that these words can be difficult to understand, so we'll have a video and we'll play that in a second. But I just want to say that sonification is a very commonly used strategy, so common that it is now the go-to for all Apple products. Apple products has a standard feature that is built in across all of their products, whether that is Keynote, whether that is Apple Watch, their health app, things like that. They all have sonification in it as an accessibility measure, right? So let's take a look. Let's hear what a sonification sound would be like. So as we heard that as the data goes up and down, the sound goes up and down. So it gives us a little bit of an idea of like, what is the graph like, right? So for example, if you're looking at a stock market trend, if it goes up, then we kind of know that it's going up, and hopefully it will keep going up because I'm so tired of this. But so if sometimes it goes down, right, and then so you can kind of tell that information as well. So it's really helpful. It's a good technique. And let's go to our next modality, which is the 3D printing. Now, 3D printing is a really cool technique, right? So what we're seeing here on the screen is like there's a software that takes the data, creates a model, sort of like a wireframe, and then finally kind of prints it out into this 3D printed 3D printed graphs, right? So for example, if a person would use their fingers to feel the graph, they can feel the data points, they can understand the visualization itself. So as opposed to all text and sonification, where you can understand the data, 3D printing can help you understand the visualization itself, right? What is on the axis? What is on the y-axis? How is the data going up and down? You can explore that on your own, right? So this is a very useful technique. 3D printers are very common these days as well. So that's one of the modalities to make data visualizations accessible, right? Let's take a look at another modality, which is tabular representation of the data. So as opposed to the other modalities that we have heard, this one gives access to the entire data set, right, to the user. So for example, there's this visualization that we're seeing, there's a graph that we're seeing, and then we're seeing a table that shows the data that the users can extract information from if they wanted to, right? So it gives us raw access to the data and it's very helpful for people to kind of get all the information that they want and to extract whatever their preferences is, right? So for example, if the user was looking for California, they might not be able to get that information versus in a tabular representation, they would be able to get that information because it's right there. Right, so now that we're familiar with these four modalities, what we'll do is something fun, and that we'll go into an activity today, right? So in this activity, what we'll do is we'll pair up with a neighbor, and then we'll discuss some of the advantages and disadvantages of these modalities that we've just encountered, right? So there are 4 of them: alternative text, sonification, 3D printing, tabular representation. Feel free to share your experiences too, and if you've implemented one of these these modalities to make visualizations accessible with each other. We'll do about 5 minutes of a discussion, and I'll make sure I announce when it's 2.5, so you can switch roles and like discuss from the other person's perspective. So let's have you guys discuss that. We'll start now, and we'll come back in about 5 minutes. But thank you for the amazing insights. So let's discuss that a little bit more. So right, we talked about alternative text, so we'll discuss each modality now. Alternative text is obviously, as we understood, that is great for holistic information extraction. It helps us understand the data a little bit from a holistic point of view, right? But what it doesn't give us is individual data points, right? So it doesn't provide us with the data points, especially because an alt text is recommended to be the size of sort of like a tweet sized, right? A length of a tweet. So in a length of a tweet, what can we say, right? So in an image, in a graphic, that's a little bit of a different thing. But when we talk about data visualizations, there's inherently so much information in it, right? So how much information can we present? So we recommend that the alt text should be used when the visualization can be sufficiently described in a tweet-sized text, right? If you can determine that that is possible, go for it. If it's not possible, then it might not be the best way to describe a visualization, right? Similarly, we talk about sonification. We heard a lot of good things about it. Sonification is great for overall trends, right? It's great to understand if the data is going up or if it's going down. But what it doesn't give us, as Nagin was saying, was that it doesn't give us the individual data points, right? So we're not able to grab the individual data points. It's also really complex to understand the difference between 2 data points or to compare them. It can also be very, very dangerous in the sense that if the axis information is not provided, like if I didn't know that the x-axis was organized in descending or descending order, the sonification response will be the opposite for both of them. That could be really, really dangerous, right? I might take away that the stock market is going down, but it might be going up. I don't know what's on the x-axis, right? So sonification without some of the information could lead to a lot of like misinterpretations. So we should misinformation as well. So we should avoid that. So we say that sonification is a great strategy when the data portrays clear trends, when the users can make out the clear sounds and what the trend can represent. If it's clear enough, then it's a great strategy for a quick sound to understand, to take away like what is the result from this visualization, to have a clear one takeaway from it. So that's where we recommend sonification. Similarly, 3D printing is great because as I mentioned earlier, it helps us understand the visualization and how it's organized. It can be helpful in understanding and learning techniques as well. For example, if you're teaching someone who's blind how to create visualizations, or how visualization looks like, or what are the visual elements and encodings are, it could be really helpful for them as a learning opportunity and a learning tool as well, right? But what is not helpful for is spontaneous web browsing, right? If you're going from one web page to the other, as one of the attendees, sorry, what is your name? D? Sorry, yes. So as he was saying that like it requires a lot of resources, right? And people might not have those resources. For example, it's hard to imagine that a person will be carrying a 3D printer with them all around at all times, right? So that's probably not going to happen. Also, in spontaneous web browsing, you might see a visualization, but what you might not see is the data of the visualization readily available to them. So taking that data, feeding it into a 3D printer, getting the 3D printed output, and then understand the visualization, I think the day has passed at that point, right? So our goal is to make it faster and equitable as like some the people who don't use screen readers. That might not be the best. So we do say that 3D printing is a great strategy when we have the data, when we have the time, and if, for example, if a user really wanted to learn about one particular thing, it could be really helpful, right? And obviously access to 3D printer is important. And finally, we discussed the tabular representation. Now, tables are great, right? Tables, I overheard someone saying that tables are one of the best things, like because we can provide the information to them, right? Now, those are great because the user can like go through and extract information. Now, what we need to understand though is that when it's a screen reader users and they're using a screen reader, the information is very linear. The navigation is very linear. So they would have to go through like each row by row and then column by column, right? So they will extract information one at a time. So then we have to think about, tables are great. What if the tables contain 100 data points, 10,000 data points, right? Are we expecting them to go through each data point? And even simple information such as like minimum or maximum, they will have to calculate that on top of their head, right? They will have to either take notes or keep remembering that, okay, this one was the last one, this one was the last one, or something like that. That is a really high cognitive overload for these users, right? So tables are great, right? But they might not be the best. So as a matter of fact, let's take a look at the graph that we showed you earlier, right? This is across different visualizations. What we're seeing is that there are, between Chart.js, D3, drastic difference. Google Charts, not so much. Why? It's because Google Chart automatically appends a visually hidden table with each visualization, right? So what that means is that with the table, their accuracy is very good. It's not that much of a difference, right, between screen reader users and non-screen reader users. That's a great result, right? We love that, right? Maybe not, because when we look at the interaction plots, what we're seeing is that the interaction for screen reader users among the different visualization libraries, Google Charts also had the highest one. So not only are we increasing the accuracy, we're also increasing the interaction times. In the field of HCI, which is human computer interaction and accessibility, that's not an ideal result. An ideal result is when we improve their accuracy and also decrease their interaction times. That is an ideal result for us, right? So we can kind of already see the pros and cons and the disadvantages and advantages of data tables through this example, right? Through this finding. So we've gone through different modalities. We've gone through the disadvantages and advantages of them. We've kind of understood when we can use them and when we should not use them. At this point, we have to ask ourselves the question of, is access to data really equitable for these users? Like as compared to someone else who doesn't use screen readers, all of these modalities, they might be equal. Tabular representation, I will argue that it is equality, but I would also argue that that's not equity, right? So are these modalities equitable for these users, right? The answer in my head is a no, but I don't want to give you that answer quite yet because that is your homework. The homework is for you to think about how can we make data visualizations equitably accessible to these users, right? You're not going to be graded for this. It's okay. Don't worry about it. Don't stress about it. But what we'd like you to do is to think about this, take it back to your colleagues, take it back to your work and future jobs, and think about like how can we make these data visualizations equitably accessible to them, right? That leads us to the final section of this workshop, which is to discuss some of the future avenues. What are some of the things that we have? What are some of the things that we have done so far that are outside of these modalities? So we'll discuss those. So I'll present my work on VoxLens, which is making data visualization accessible for screen reader users through an interactive JavaScript plugin. This work was published at 3 different venues in 3 different publications. So what is VoxLens and how did it start? It's actually very simple. So we have these voice assistants all around us, right? We have Google Home, Siri, Alexa. We talk to them, we love them, we hate them, all of those things, right? But one of the things that is really, really great about them is that we can ask them a question and they can give us an answer back, right? So the idea behind VoxLens was exactly that. Can we enable these users to ask a question from the visualization and just get the answer back? And they don't have to do anything else, right? Would that approach work? Turns out it did, because VoxLens is the first multimodal solution to enable these users to interact with and extract information from online data visualizations using voice-activated commands, right? The key terms here are multimodal. I heard someone say that one of these modalities is not going to work, a combination would. And that's what the approach behind this is. Providing users with all of the modalities so they can get the benefits of each one of them while also introducing a new modality was the goal of this work. It was the first work and the only work that exists today. It is deployed for anyone to use as an open source JavaScript library that anyone can use. And we'll talk about that in a second as well. It's the first work of its kind and uses a multimodal solution. Let's take a quick look at how a user will be able to interact with VoxLens.
Tell me about the minimum and the median and also the standard deviation.
It seems like you asked about the median, minimum, and standard deviation. Median of total number of cases for state is 1,003,158. Minimum value of total number of cases for state is 108,577 belonging to Vermont. Standard deviation of total number of cases for state is 1,692,465.67.
What is the data for California?
It seems like you asked about the value. Found the following possible matches in the data. The value for California is 8,767,944.
So as we saw that a user was able to press a key combination, ask a question, and get the answer. Whether that was statistical data, whether that was individual data points, they were able to get that information. This way they can ask information about multiple data points as well, sort of like compare the two as well. So it gives them the opportunity to do so and extract information pretty quickly, pretty fast. And the great part about that is the user does not need any hardware installation or software installation. They don't need an extension. This just works right out of the box, as long as the library of VoxLens is integrated by the visualization creators. Now, what does that really mean? The integration of the library. So what we have here is that an example of a D3 visualization. VoxLens only requires a single line of code for integration, right? So as long as the developers put that line of code in their visualization, everything else is done automatically. Everything is, they don't have to worry about anything. The screen reader users don't have to worry about anything. So that kind of reduces the burden on these developers in implementing accessibility, because then there's a standardized solution that can be applied to every single visualization online. It stays consistent as well, right? So one web page, it doesn't have a different visualization accessibility versus the other page. They're all the same. So user feels more comfortable with it, right? As a result of VoxLens, what we noticed that in the beginning, you would remember that 62% less accurate was the result that we saw. We were able to flip the side on that and make it 6% more. So the idea behind that is that if we give users the right tools, they can extract information just like anybody else. That 62% less accurate is only because the technology is not accessible. Right, so that's the important takeaway from that. Another thing was that we reduced the interaction times from 211% to 56%. That's a drastic difference. That's a very significant change. 56% is still a lot, but we have to also think about that we're able to process information in our brains just by quickly looking at it, and they have to listen to the audio, ask the question and that has some milliseconds to it, right? So that's why we probably would not be able to get that to a 0% ever. With this technology, but it is a drastic change, a positive step forward, right? Let's take a look at some of the qualitative results. One of our participants said that I've never been really able to extract information online. I mean, like there's a lot of visual graphs and I don't have access to. So so I could see myself using VoxLens a lot. The tool is really great, definitely a positive step in creating accessible data visualization, right? Another user said, talked about the high impact of the question and answer mode. They said that I especially like the part of the tool where you can ask it a question and it would give you the information back. Like I thought it was brilliant. Actually, I felt like being able to ask it a question made everything go a lot faster and it took a lot less brain power, I think. I felt really confident about the answers that was given back to me. So some of these tools, like leveraging what the technologies around us and making them and bringing them into the field of accessibility could be really, really helpful as our takeaway from this, right? So this is the link to the open source library that you can use. It's an open source library, so you can use the code if you want to. You can contribute it as you want to. A lot of people have already done so. So we encourage you to kind of look at this library if you feel like it. Now, what we have so far seen is that, like, if we think about the results, right, and we said that initially the ideal result for us would be to increase their accuracy, reduce their interaction time, right? VoxLens did that, and pretty significantly as well. So does that mean that we're done? Does that mean that this is a complete solution? Does that mean like all of our problems are solved? We've solved the problem of disenfranchisement and inequity issues that people face? The answer to that is no. But the answer to that also lies in the homework number 2. So the other homework for you all is to kind of think about how can we provide users the agency to customize the information they consume from online data visualization, right? So we're thinking about alt text, right? Alt text is auto-generated, or we generate that and we give that to the user, right? What is the underlying assumption behind that? The underlying assumption is that that single alt text will just magically satisfy the needs of 2 billion people in the world. We have the opportunity to extract information individually based on our unique preferences, and they don't, right? So how can we enable them in controlling the information that they see and having the agency to do that, right? We heard sonification. What if someone doesn't like that sound? What if that hurts their ears? What if they like musical sounds? They should be able to specify that information, and systems should be able to adapt to it, right? So this is the homework number 2 for you all, to think about what are some of the ways that we can provide them with the agency. Another thing to think about is that what we have discussed so far today is the consumption of information. What we are saying is that how can we make accessible online data visualization so people can consume information from it. What we haven't talked about is how can we enable these users to produce information. These users should be able to produce information too, right? They're not just the consumers, they can be producers as well, right? Why limit the field to people who do not use screen readers to create visualizations? Let's open the jobs for everybody, right? So that leads us to another question, promise is the final one. But how can we enable screen reader users to create visualizations, right? So that's, again, like as a summary of the homework, there are 3 questions for you all to think about. Take it back to your colleagues, friends, and discuss these questions in how can we improve the world of accessibility beyond the common modalities that are already out there. And think of like creative ways and creative interaction techniques which can enable these users to do things more effectively, more efficiently. Some of the other resources that I would like to present, we won't have a chance to go through those, but their chart reader, which is from Microsoft, also an open source library, Chartability. That's a tool that was created by Frank Lavsky that evaluates the visualization for accessibility. And then there are 10 guidelines for data with accessibility from HighCharts, which in itself is not very accessible, so fun stuff. But these are really cool resources. I would encourage you to take a look at it. With that said, thank you so much for attending this workshop. I hope you learned something new, and I hope that was motivating and inspiring for you. There is a QR code that is the post-workshop survey. If you took the pre-survey, please take the survey as well. It would really help me in my research. There's a link and a QR code to it. I have my emails on this email on this slide and my website if you want to learn more about my work. There are 2 cats. They're my cats. They're turning 2 soon. So that's Harry. That's Harry on the right, Gemma on the left. I promised them that I'll put the pictures on my presentation, so that's promise fulfilled. But now I'll open up for any questions that you have for me while you fill out the survey. Any questions that I can answer, any feedback, any comments, anything that you would like to share with us.